Hello, everybody, and welcome to video 2 of our 4-part series on building large language model applications. In this video, we're going to go through inference engines and prompting. So we're actually going to spin up a model, the open source model we pulled down earlier. We're going to spin it up with vLLM, which is a really awesome open source inference engine. There's other options out there, but we'll opt for vLLM in this case. Real quick note, I am running out of the same notebook as last week, and in between each of these videos, I come up to runtime and hit disconnect and delete runtime, and I restart. Uh, and that just tends to help kind of keep things clean so that I don't have anything on my GPU and everything's nice and wiped clean. So just keep that in mind if you're using the same notebook. If you haven't, cleared anything out since the last video, you may need to do that before hopping into this. So let's talk about so while this is running, I've already installed these, but while this is running for you, let's talk a little bit about these packages. So again, vLLM, that is our inference engine. What it allows you to do is instead of having to tokenize and detokenize and process all the inputs yourself, vLLM allows you, and inference engines generally allow you to provide the large language model to it, and then it serves it up for you to interact with like you were talking to any other API. And the nice thing is that it handles scaling, batching, uh, all the extra performance little tweaks and tunes for you, and also provides some really great configuration for things like context window and batch size and all of that. So we'll take a look at that in a second, but it really helps kind of simplify the process. We're going to install the OpenAI library. So the nice thing is that vLLM and many other inference engines out there will actually mirror OpenAI's API spec on their API. What this means is that we can talk to our open source model here as if we were talking to GPT. So if we wanted to pull in a different open source model, use a different inference engine, or even talk to OpenAI itself and talk to like GPT-4, we could do that, right? We could just swap out the backend because the calls are basically the same. And then bits and bytes again, we hit on that in the last video. That's just so that we can use our quantized model with vLLM. So let's take a few minutes to run, and then we'll hop into actually spinning up vLLM. So to do this, um, you can copy this here, and I'll step through this. You can go down bottom left, you click terminal. This will open up a tab. I have this running right now, but the way you would spin this up is you can right click, hit paste, and hit enter. It'll take a few minutes to pull down the model and start up, but that just kind of gets the vLLM inference engine started. So I'll talk through this real quick while that's starting. It'll probably take a few minutes. So again, we point at our model ID. We're going to set the host and the port. So we'll set the port 3000. You can set it to 5000, 6000, 3050, whatever you want to set it to. But I'm setting it to port 3000. The max model length is 2048. So this is where I'm setting the context window, right? We talked about context window in the last video, but just to refresh, right? It's the maximum number of tokens that can be in the input and the output. So the total tokens that can be processed at one time for an input or for a query, excuse me. And I'm setting it to 2048 for space saving reasons. But a lot of these models, you can set this up to like 100,000 tokens, but we don't have a ton of GPU space, so we're going to set it a little bit lower. Max number of sequences, again, just for space savings, I'm putting this to 2. So this is basically the number of the batch size. So imagine you sent like, in this case, we can send 2 queries at the same time. They'll be batched together. But if we had more VRAM to work with, we could set this like 64 or 128 and process more at a time. And then D type half, this is just setting the data type for the model to float 16 instead of 32. So it's just reducing that space a little more. And again, this is all because we have kind of limited VRAM, and these are good space saving options. But if you have more VRAM to play with, you can obviously do higher precision, higher context window, things like that. So once this is all done spinning up, we'll come back and we'll actually look at sending our first inference request. All right, so we have vLLM running. Um, you know that it's running if you have the application startup completed here, and you'll see all the endpoints right above it. So with that started up, we can start chatting with our model. Now, again, the nice thing here is that because OpenAI's API is reflected on vLLM, we can actually talk to it just like we're talking to ChatGPT. So we're going to set our system message first. So the system message and the user message are pretty common among chat models. Um, some models will have some like different types of messages, but generally these are the two you're going to see. So the system message is where we're going to define the personality of our model and give it some instruction. In this case, we're going to say you're a helpful technical assistant. Uh, Given user query, provide a clear and concise answer. We'll look at how changing that affects the output in a little bit, but we'll keep it basic for the first input. And then we'll set the user message template, which in this case is just going to be, hey, below this is the user query, and then we'll format our query into these brackets here. So we'll set up our client. We will point at localhost port 3000 and /v1. So port 3000, right? That's where we're serving our model up. And then we will set our query to what is the capital of Spain. And so we're going to format that into our user message, right? So we're going to do a dot format. It's going to set this query block here to our query. And then we're going to define our list of messages. So our list of messages here, each of them is going to have a role and content. So the role is sort of like a label, right? We're labeling what this message is. So the first one is the system message. So the label for it is role, or the label for the role is system, and the label for the user role is user, right? So we'll set system for system message and user for our user message. And then when we send our inference, it's actually quite simple. We just say OpenAI client chat completions create. We give it the model ID that we're serving. We give it our list of messages, our temperature. Again, we're just going to set it really low to keep it pretty deterministic. And then we're going to set our max tokens to 128. So again, that's the number of tokens that it can generate in its answer. And so we'll get our response here, and it's usually in this format of dot choices. So you'll have a list of choices. We're going to get the first choice, the message, and the content. This is almost always how you're going to access the answer. And it's, hey, capital of Spain is Madrid, right? So congratulations, we answered our first question using a model. We answered it. We hit vLLM. All is well in the world. But now let's try and change the personality, right? Let's take a look at how changing the system message affects the input. So in this case, we're going to say you're a grand old wizard that answers questions mystically. Right, so we'll keep the same exact query. We're not going to change anything else. We're not going to change the temperature, the model, the tokens, anything like that. We can see here we now get a much different answer. In the realm of the mystic, the capital of Spain is not a known fortress hidden in the midst, but rather a city that echoes. Right, so we get this much more unique answer just by changing the system message. So again, it's just a little bit about how you can change like the personality and get different answers. So let's take a look at maybe a little more practical example. Let's say that we wanted to perform sentiment classification, right? So given a user query, we want them to classify it as either positive, negative, or neutral, right? So we got three here. I love that book, obviously positive. The book was about dragons and castles. That's obviously just a neutral statement. And then the book had poor pacing. This is going to be obviously our negative. So we'll loop over these queries, and for each of them, we'll format the user message. And then we're going to output the sentiment. And we see that it says positive sentiment, neutral sentiment, and negative sentiment. So we got them right, right? So some, we performed some sentiment classification using our model. So that's just a little bit of a look at how we can change up these messages to perform different tasks, have the model, act or answer differently. In the next section, we'll look at different prompting techniques, starting with constrained output. All right, so starting with constrained output. In the previous section, we did some sentiment classification, right? Now, if I was running this in a program and I wanted to be able to pull out whether it was positive, neutral, or negative, sure, I could do a basic like string search and look for the word positive or look for the word neutral. But what if I want to have a really, deterministic and reliable output that I can expect to look the same every time? Well, this is where something like constrained output can become very full. So we're going to use this library called Pydantic. If you're not familiar with it, just kind of allows us to define like schemas for data. And we're going to find a sentiment classification model. So it's going to have two fields, sentiment and reasoning. So sentiment is going to be a literal, which means it can be one of these options, positive, negative, or neutral. So that's where we're kind of constraining. And then the reasoning field is where the model is going to kind of explain and reason about why it classified something a certain way. And we'll define our system message. We're gonna change it a little bit. We're gonna say, hey, your outputs are in a JSON format now, and here are the fields that I want. I want a sentiment. It's going to be a literal with these options, and then reasoning, which should be of a type string. So we're going to give it the same queries. We're going to do the same for loop, but you can see now we're passing in an extra field here, extra body. So this is a vLLM specific thing, but a lot of inference engines have something very similar. We're going to give it a guided JSON value, and it's going to be this sentiment classification model with the JSON schema. So let's run that and see what we get. And you can see that we end up actually getting valid JSON objects for the response. So we could pull out the sentiment, right, which we did here. We can pull out the sentiment and the reasoning and then act on those accordingly, right? So if we wanted to store all the positive ones in one place or all the neutral ones in one place, we could do that. So again, it's not 100%. Now, it's important to remember, again, this isn't 100%. It can still mess up the JSON format, but it definitely helps guide the generation and give you a much higher probability of getting the format that you expect. And you can honestly add to that a lot by just improving your prompt, right? So um, adding in this explanation of the output format also really helps. I've seen sometimes if I don't kind of describe it here, even if I have this extra body set up, sometimes it still doesn't give me the output I want. So putting this in the prompt and saying, hey, here's what your format looks like, or even giving some examples can be really powerful. So that's an example of how we can constrain output of a model with vLLM. All right. So now let's take a look at one and few shot prompting. Starting with one shot prompting. One shot prompting allows us to basically give the model an example of how to do something to help guide the format. So, given in this case, given the user's details on a vehicle, create a JSON object out of it. So, in this example that we give inside the prompt, right, we're going to give it some details and then we're going to give it what we expect the output to look like. And this is called a shot, right? So it's one shot because it's one example. Um, Pretty simple user message. We're going to say, hey, kind of reiterate, given the user's vehicle details, create a JSON object. And then we're actually not even going to constrain it this time. We're just going to take a look at what it produces here. And what we'll see is it actually gets it right. So again, you could use this sometimes in conjunction or even in place of uh, that extra body, depending on the task. You can see that by just providing an example, we were able to kind of get it to answer in the format we wanted, which is really awesome. And we can actually see what happens if we take this example out. Let's see what we get out of it and see if it's any different. Now, sometimes models are smart enough to actually produce the JSON like valid out of the box, but it really depends. So yeah, you can see here it actually it output this and then it wrapped it in a JSON block. Of course, we could parse that, and it's not the end of the world, but it is sometimes useful to provide those examples so you can get the exact sort of output that you're looking for. And few shot prompting is kind of just a build off of this. So instead of one example, you give multiple examples. So sometimes people will say, like, I used a 5 shot prompt. That just means they put 5 examples in here. So in this case, we're just going to add in a few more examples. Now, because this is a fairly simple task, it's going to do a pretty solid job at it. But again, that's just to kind of reiterate the difference there. You can see the answers are um, pretty similar to what it was last time. But again, it's just sometimes adding in more examples can really help kind of guide it, especially as your tasks get more complicated. Those examples can become really important. We'll actually see those examples in action in our agent. And that does it for one and few shot prompting. All right, and finally, we're going to take a look at chain of thought prompting. So this is a pretty popular technique. We're not going to get too deep into it here, but we'll look at a really basic example. So typically, chain of thought prompting is used to help LLMs kind of break a problem down step by step. And this can be really useful for complex problems, sometimes math problems, or for like planning out a set of steps to run. So in this case, we're going to say, given a query, provide a clear and concise answer. And for our reasoning, so this is our basic system message. In our reasoning system message, we're going to give it a little more guidance. We're going to say, start by considering what they're asking for, reason about how to best answer their query, explain your thought process, think about the problem step by step, and then provide a final answer. And what we'll see here, I'm going to actually, what we're going to do is we're going to run the basic system message through, and we're going to print that out. And important thing to note here, I'm setting stream equals to true. So what this will do is instead of providing the answer like at once, it'll actually stream it out to us. You don't have to do this, but it's a nice. It can be nice to see it kind of stream the answer back. So you'll loop over it and you grab. It's a little bit different. You'll do choices delta.content instead of message.content. And I ran this because it took a few seconds, but you can see the answers are pretty similar and they actually come to the same final answer. But you can see that the first one, it does break it down step by step, but the second one gives us arguably maybe a little more verbose and useful information where it kind of explains what it's doing with some of the steps. Again, this in this case, because it's a fairly simple now, integrals being fairly simple is up for debate, but a fairly simple math problem. But you can imagine as you ask much more complex things that sometimes these um, having this extra kind of verbosity where it explains what it's doing can be really useful. Um, and oftentimes, this chain of thought prompting is used internally in a lot of agent libraries for kind of breaking something down step by step. And that about does it for our prompting and inference techniques. So to recap, we spun up vLLM, we ran some inference requests against it, we played around with constrained output, one and few shot prompting, and even tinkered a little bit with chain of thought. These are again all just kind of scratching the surface. We kept things pretty simple, but again, just highlighting some of those things you're going to see and hear as you're dipping your toes into the world of LLM building LLM applications. So that does it for today's video. In the next video, we're going to go into RAG. We're going to build a simple RAG pipeline from scratch. Personally, very much looking forward to that. It's probably one of my favorite LM methodologies. So that about does it. Hope to see you in the next video and have a good one. Bye.